Hello and welcome back to my YouTube channel. In this video, I'll be going through the solution to exercise 2.6 from the C programming language textbook by Brian Kernighan and Dennis Ritchie. Now exercise 2.6 says to write a function setbits that returns x with the n bits that begin at position p set to the rightmost n bits of y, leaving the other bits unchanged. Now that might sound a bit confusing, but what it essentially says is given two unsigned integers x and y, as shown here, suppose you have the last n bits of y set to something, then starting at position p, which would be the position where the cursor is at now, set the n bits on from that equal to the last n bits of y. This kind of like visualizes what it would look like. So as you can see, we've just copied the last n bits here starting at position p. So the first thing we should do is get the last n bits from y. Now how do we do that? Well, I've typed this up here just to show how we could do that. Suppose we have, actually this would be better to be all y's. So we have y, and let's say we want to get the value of the last n bits. Well, what happens if we AND it with this value with ones in those last n bits? Well, let's see. Y, well, this first digit ANDed with 0, well, anything ANDed with 0 is 0. So all these bits turn to 0. Then here, let's look at these two. 1 ANDed with that first n is going to be whatever n is equal, because if n is 1, then 1 AND with 1 will give us 1. If n is 0, then 1 AND with 0 will give us 0. So whatever n is going to equal will be this bit here. Likewise, for the remaining 2 bits will also be n. So to get the last n bits from any digit or from any integer, all we need to do is do a logical AND with ones in the position of those last n digits. So let's do that here. I'm going to have this value. Should I have it? No, I'll have it as an integer. Integer last n bits should equal. Well, how can I get a 1 like in the last n positions, right? How can I do that? So what I can do first is take the negation of 0, which is just going to be filled with ones. Then I'm going to move it n bits. So if I have something filled with ones and I move it over n bits, those last n bits are all going to be 0 and everything else is going to be 1. But that's kind of like the opposite of what I want. So what I do is I take a negation again, right? And now all I have to do is do a logical AND with y. And now I have the last n bits of y. Now what I need to do is move like those bits over to position p. So I'm going to call, well, move bits over to position p. And I want to store this in a new integer called, I don't know, setbits, and it should be whatever last n bits was. And then I should shift it over, but by how much? Well, I want this, if I'm shifting, I want this n to move over and be this n here. And so if this is at position p and this is at position n, then really the number of bits I'm going to be shifting is going to be p minus n. Okay. Now we're nearly done. We might be tempted to just now straight away manipulate x, but we have to be careful. We need to first clear those n bits starting at position p in x, then we can do whatever we want with it. So we should first, if this was x, we should set this bit, this bit, this bit, this bit, and this bit to 0 first. We should clear the bits, that is to say. So clear bits in x starting at position P. Now, how can we clear it? So I'm going to first store it in, I'm going to do it like this. I'm going to say what I want first is an integer or a value of bits with 1 everywhere. So here would be 1, 1, 1, 1, 1, 1, except at the position n, I want zeros. So I would like to have a number where I have 1, 1, 1, 1, 1, 0, 0, 0, 0, 0, 1, 1, 1, 1, 1. So everywhere ones except those n bits. I want those to be 0. And then what I can do is do a logical AND with x. So let's first get this first issue out the way. How can I get a value with only zeros in those n positions? So first thing is I'm going to negate 0 and I'm going to move it over by n. So now what we have is ones everywhere except in the last n positions. In the last n positions we're going to have zeros. Then I'm going to negate this. So initially we had ones everywhere, moved it over n positions, n bits, and so what we have is 1, 1, 1, 1, 1, and then the last n bits will all be zeros, and then we negate it, so now we'll have zeros everywhere, and the last n bits will be 1. Okay? So the last n bits are 1. Let's now do a shift on those last n bits, and we'll move it p minus n. Now this is starting to get a little confusing, so let's stop for a minute and see what we have now with this. What we have now with this is these bits all set to 1 and everything else set to 0. This is the opposite of what we want, and so we negate one more time. And now that will give us the cleared bits. And then we should reset x to be x ANDed with those cleared bits. And now x has those bits, those n bits, cleared. And now to set those bits to the last n bits of y, all we need to do is a logical OR. So like this, and setbits. And here we have just a small example. I've done some of the binary conversion beforehand, but we should expect 248 as printed out on our standard output. So let's compile this. Hopefully we get no errors, but it's quite a confusing exercise. Yep. Okay, looks like we have a typo. Oh no, we're missing semicolon. Try again, okay. And look at that, we get 248. Now that will be all for this video. Thank you all for watching, and I'll see you all in the next one. Bye bye.